Hello and welcome to the third part of the Vapour compression system, which is application of VCRS. This is the extension part of the Vapour compression system. In this part, we will be studying different applications of the Vapour compression refrigeration system. This session is conducted by Ms. Anukriti Sakre and Ms. Shruti Vidpathak. This work is licensed under a Creative Commons Attribution, Non-Commercial, Share Alike 4.0 International License. So we will see what are the different applications of a refrigeration and air conditioning system. These are some applications which are listed here. First one is domestic refrigerator. The refrigerators which are generally used for the household purposes. Next one is automotive air conditioners, the air conditioners which are used in the automobiles. Next is evaporative coolers. Next are the water coolers, ice plant, commercial refrigeration, etc. These are the few applications listed here. From the above few applications, some of the applications are listed or explained in the following slides. The first application is about the domestic refrigerator. The main components of the domestic refrigerator are evaporator, compressor, condenser and expansion valve. So in this figure we will see where are these components are located. This is evaporator. Generally the evaporator is located in the freezer section where the heat is absorbed from the surrounding in the refrigerant, and then it is supplied to refrigerant is supplied to a compressor. In the compressor, the refrigerant is compressed to a high pressure and high temperature refrigerant. Then that high pressure refrigerant is sent to a condenser. These are the condensers coil which are at the back of the refrigerator. Then after condenser, the temperature of the refrigerant reduces, but the pressure of the refrigerant remains constant. Then that high pressure, low temperature refrigerant is sent to an expansion valve here. After expansion valve, the temperature and the pressure of the refrigerant reduces below 0 degrees Celsius, and that low pressure, low temperature refrigerant is sent to an evaporator. So the cycle continues. The cooling effect is obtained in the evaporator section, that is in the freezer section. The rest of the compartments of the fridge gets cooled with the help of a natural convection. Means the air which is in the vicinity of the freezer section gets cooled. That cooled air, being in higher density, settles down at the bottom of the fridge, and the warm air which is at the bottom of the fridge comes in the vicinity of the freezer. So this forms a natural convection inside the fridge compartment, and we get even cooling in the fridge compartments. The next application which we will see is automotive air conditioning system. R134A or HCFC 134A is used as a refrigerant in automobiles. So basically in the cars or in the trucks, the air conditioning systems are installed. So these air conditioning systems cools and removes the excess moisture from the car cabinet. Main components of the air conditioning systems in the automotive air conditioning is compressor, the compressor which is attached to an engine shaft, condenser in front of the radiator, receiver dryer contains desiccants. Desiccants means the components which absorbs the excess moisture from the refrigerant. Then the expansion valve which reduces the pressure. Evaporator located in the cabin compartment, usually above the footwell on the passenger side. Fan blowing over a evaporator coil blows cool air to a passenger side. So this is the diagram for the automotive air conditioning system. This is our compressor. The compressor compresses the air or refrigerant to a high pressure, high temperature. Then this is condenser. These condenser coils are fitted in the area of the radiator. Then that condenser condenses the refrigerant. The fan may be provided or may not be provided. Depends upon the applications of the or the construction of the compressor condenser. That high pressure, low temperature refrigerant is then sent to a dryer, where if there is any moisture or any dust particles are there in the refrigerant will be removed. Then that refrigerant will be sent to an expansion valve, where the refrigerant is expanded and the temperature and pressure of the refrigerant is reduced. That low temperature refrigerant is then passed through a evaporator coils. The air is blown with the help of a blower over the evaporator coils, so that you will get a low temperature air in the cabinet of the car. The next application is evaporative coolers. So the evaporative coolers are also called as desert coolers, which uses evaporation method to get the cooling effect. The evaporative coolers are generally used in the summer conditions. Evaporation principle is applied here. The components are heat insulation, cool humid air duct to fan, vibration absorber, blower motor, hot dry outdoor air, variable evaporative pads, overflow tube, ball float valve, tap water, water pump screen, recirculating water pump, blower, water distribution lines. Working of evaporative cooler is very simple. The water is pumped from the water sump to a water distribution lines via recirculating pump. So this is your recirculating pump, and the water is pumped from this water sump to the water distribution line. This water in the form of droplets is passed over a wood-wool evaporator pads. So the water is passed over these wood-wool evaporative pads with the droplets forms, which helps the air to get cooled. The blower is fitted inside the cabinet of the cooler. So this is the blower. This blower blows the cold air and draws the hot air from the surrounding. So the hot air is drawn from the surrounding inside the cabinet of the evaporating cooler. When the air is passing over the wood-wool pads, the latent heat of vaporization is absorbed by the water present in the pads, and the water converts into vapor. Since the air being hot outside the evaporative cooler, this hot air evaporates the water which is passing over the wood-wool evaporator pads. So there is a heat transfer takes place between the hot air and the water, and that heat is utilized in the vaporization of the water. So the air being cold is then sent to a room via air duct. The next application is water coolers. Water coolers are basically the machines which provides cooled water as per the requirements. So the components are again the same components of the vapor compression cycle. Compressor, this is condenser, then this is dryer, expansion valve, evaporator, and again to the compressor. The reservoir is kept topped up either from the large plastic water bottle or from a water main system. So there are two types of water coolers. Either a large water supply is provided at the top of the cooler, or directly the water supply is provided from the mains. The refrigerant system works in almost exactly the same way as your fridge at home. The components we have already seen. The working is same as a domestic refrigerator. So the compressor compresses the refrigerant to high pressure, high temperature. That refrigerant is then passed over a condenser. There is a condenser fan which helps in the condensation process. That low temperature, high pressure condenser refrigerant is then passed to an expansion valve, where this refrigerant expands to a low pressure and low temperature refrigerant. So here around the evaporative coils, the main supply of water or the large water bottle supply is provided. So here we can get the cooled water as per the requirements of applications. Thank you.